Good morning, everyone. It's a pleasure being here today. So just to comment on Asher's talk, I loved your talk, and I was actually at an overcoming an imposter syndrome last year when I went in a very downhill period during my PhD, which I think every PhD student has to go through. So as soon as I was there and I was speaking to one of the girls who was enrolled in a PhD program doing history, and she was writing her thesis, and she said, I feel very worthless. I don't think my work is worth anything in this world, and I'm wasting so much time. I mean, look at those people curing cancer. Look at those people dedicating their lives to find cure for people with cancer. And at that point, I just had a minute of silence because I am a cancer researcher myself. And I did think my work is worthless, and I did go through that as well. So just for every PhD student out there, anyone who is feeling like they're not enough, talk to people around you. Everyone is going through the same thing, and being part of the same boat actually helps you motivate and get through these sort of things. So my talk today is about part of my PhD project. So viruses. The first thing that comes to mind when I mention viruses, those tiny parasites that cohabitate our planet, is pathogens, mass serial killers, which is true. Viruses, nothing has killed more people on our planet like viruses have. Smallpox, for example, has a shocking number of an estimate of killing 500 million people in just the 20th century. Other viruses, measles, polio, rabies, have killed hundreds and thousands or millions of people over the years. The exciting part is that can we harness the power of those viruses for cancer precision medicine? Can we actually tame those dragons? Can we actually make them of use and portray them in a way that is not what we actually see from this fire-breathing image of dragons? And I'd like to tell you that it is true, it is fascinating. It might be a scary idea, using viruses to treat cancer cells. It's scary, it seems dangerous, it seems like out of a science fiction. But if we go back into history and think about how scientists and researchers actually went to the nature's most devastating forces to treat cancer. I'd like to read out this quote that stuck to my head. So, steel in the hands of a soldier kills, but in the hands of a surgeon extracts tumors. Poisons in the hands of a general can annihilate, but in the hands of an oncologist can kill cancer cells. Radiation spewing can melt from a nuclear meltdown can melt landscape, but in the hands of an oncologist can melt away the tumor. So all of these ideas make it fit for viruses to be used to treat cancer. The concept of using viruses to treat cancer cells isn't a novel concept, and it actually dates back to the 1950s when people with incurable types of cancers came into the clinic after acquiring natural infections of viruses, and the cancers just went away. One of the most famous stories is this boy seen in this article that was published in 1971. He had a Burkitt's lymphoma, which is a lymphoma, and he had a lump on his orbital right eye side. And upon getting measles infection in Uganda, where he's from, the tumor completely regressed. There was no cancer. The cancer just went away. So that was very intriguing, very fascinating for scientists. But at that time, we didn't have the tools to understand how this might work, how we can make the viruses more specific to cancer cells. We didn't have the genetic technology to allow us to create genetic or synthetic designer viruses, if you'd like. So with the recent advances in science, wild-type viruses, which are naturally occurring, were adapted in the laboratories to be more attenuated and for use for vaccination. And those are the viruses that are actually used to cure or to try to treat the cancer. Additional arming of the virus. So if you look at it, it's a dragon that does not have any teeth. So it can do the job by itself, but we can actually potentiate and make the virus more efficient at killing cancer cells by adding more teeth or adding more therapeutic genes. So what are oncolytic viruses? Onco is the Latin word for cancer, and lytic means killing. They are viruses that preferentially infect, and therefore they replicate in tumor cells while leaving the surrounding normal cells relatively unharmed. So in this scenario, you've got the oncolytic virus. You infect the healthy cell. The healthy cell remains undamaged because it can fight off the virus infection. Whilst on the other hand, when an oncolytic virus infects tumor cells, it can replicate within the tumor cell and leads subsequently to the cell lysis. So the cell just breaks down. Once the cell breaks down, it releases what is known as tumor antigens. So those are red flag for the body's immune system, for all the immune cells, T cells, your B cells, your neutrophils, everything to attack the cancer cell. So there's a number of oncolytic viruses currently in clinical trials with a special attraction to herpes simplex herpes virus, which is genetically engineered. And this was the first FDA-approved oncolytic virus for the treatment of melanoma skin cancer in 2015. My focus of interest is measles virus, which is ongoing in a number of clinical trials, mostly at the Mayo Clinic in the US. And one very successful story is the story of a patient with multiple myeloma who is still cancer-free, who is in complete remission actually, 6 years now, because this article was back in 2018, so 6 years now after treatment with measles virus, oncolytic measles virus. So how does the virus act? How does it recognize the cells? Cells have receptors expressed on their surface. And measles virus recognizes 3 different receptors. So once it recognizes those receptors, it binds to the receptor, and once attached, it fuses into the cell. The infected cell fuses with the neighboring cells and gives what is called a multinucleated syncytia. What makes the virus so smart to differentiate between normal cells and cancer cells? Ironically, an evolutionary mechanism of cancer to protect itself from the body's immune system is to overexpress one of those receptors, which attracts measles virus to it. This is only half of the story. My project focuses on finding genetic abnormalities in the cancer cells that makes it more permissive to the virus, that alerts the virus and allows the virus to get into the cells and infect them in a different way than they do with normal cells. I have recently identified a gene that acts as a restriction factor for measles virus infection, and it is currently being reviewed by the Journal of Molecular Therapy, and it's a very good, okay, my time is up, and I'm right at the end. So thank you very much for the opportunity to share some of what I have been going through with my PhD. Thank you very much.